Alright guys, today we're going to be talking about how finding the zeros of a polynomial function can be applied to a real life situation. Alright, so we have a problem asking us find the radius of the silo. And if you're unaware what a silo is, it's just a place where they store grain. Okay, so to the right we have a picture of what a silo would look like. You can see on the base we have a cylinder and on the top we have a hemisphere. All right, and we're given the information that the height of the cylinder is 20 feet and that the radius is going to be the same for both the hemisphere and the cylinder, and it's just R. The total volume of the silo is 864 pi cubic feet. All right, well, like the problem says, we're going to solve this by finding the zeros. All right, so we're going to figure out what that radius is by finding the zeros. So if you've been following along, we've been finding the zeros of polynomial functions. We know how to do this. However, for this problem, we don't have a polynomial function. So that being said, we need to create one so then we can go ahead and find the zeros. All right? And the zeros are going to be our answer here for the radius. So what we need to do is create a polynomial. So in order to do that, we need to know what the volume of a cylinder is and what the volume of a hemisphere is. Well, the volume of a cylinder, okay, I'm going to write it as VC, is going to be equal to pi radius squared times the height. The volume of a hemisphere, okay, well, in order to know the volume of a hemisphere, we need to know the volume of a sphere. All right, so the volume of a sphere is going to be 4 pi radius cubed all over 3. That is the volume of a sphere. Now, a hemisphere is going to be half of that, so if we just simply divide this by 2, that will be our volume of the hemisphere. So when we do this out, we get 4 pi radius cubed all over 6. Okay? Well, knowing that, we now have what the volume of a hemisphere is. We have the volume of a cylinder. Well, if we add these two together, it should equal our total volume, which is 864 pi cubic feet. So why don't we go ahead and do this? So if I add the volume of a hemisphere, so 4 pi cubed all over 6 plus the volume of a cylinder, this is going to equal my total volume, which is 864 pi cubic feet. And we're going to leave out the units here. Now at this point, we want to go ahead and start filling in some known values. Well, we know the height of the cylinder, so we can fill that value in. So let's rewrite this as 4 pi, right? This is going to be plus 20 pi radius squared. This is going to be equal to 864 pi. All right? Again, we're trying to solve for R here, so we want this to look like a polynomial. So in order to do that, we're going to have to get rid of this denominator here. So we're going to have to multiply each term by 6. So we're multiplying by 6 here, 6 here, and 6 here. That will cancel it out, right? And when we do that, we're going to get 4 pi radius cubed, right? And then 6 times 20 is going to be 120, so plus 120 pi radius squared equal to, and 864 times 6 is going to be 5184, okay? And this is pi, and that's a 4, sorry. So 5,184 pi. Well, looking at this, we can actually simplify this down a little bit further. Notice how all these terms have a pi. So we can divide each term by pi to get rid of the pi. All right, and when we do that, we're going to be left with 4 r cubed plus 120 r squared, and this is going to be equal to 5,184. Well, remember here we're solving for the zeros. The zeros will tell us the answer. So we want to set this whole polynomial equal to 0. So we're going to simply move this 5,184 to the left. So we're going to subtract it. And when we do that, we get 4 r cubed, right, plus 120 r squared equal to, minus 5,184, and this is all equal to 0. And at this point, we can try to reduce this a little bit further. It may look like each one of these terms, we may be able to divide by 4. So why don't we try that? We're going to divide each one of these terms by 4 to see if we can reduce it a bit further. So if I do 120 divided by 4, that's going to be 30. 5,184 divided by 4. Okay, so we can do that. So what we're going to do, we'll rewrite this because we're just divided by 4 here. Our final polynomial equation. Okay, so we divide each term by 4. And again, you don't have to do this. This is just to clean it up a bit. So we're going to get r cubed plus 30 r squared, and then minus 1296. And this is all equal to 0. Okay, so here's our polynomial equation. So at this point, what we've been doing, okay, we've been trying to factor this to get the zeros. Well, it looks like we can't factor here, so the other option was to use the rational root theorem. Now, for this example, okay, that's going to be a lot of work, so that is why having a graphing calculator really comes in handy. So what we're going to do, since we have it down to this part now, we're just going to simply put this polynomial function into our graphing calculator and determine where it's crossing the x-axis. All right, so when we do that, we plug it in, all right, and we get a picture of what's going on. And I'm going to draw that picture out on here so you can get a better representation. So we have, and it's going to be a small picture, so keep that in mind. Here's our grid. All right. And going from left to right, we have something like this. It's going up, it comes back down, and it goes back up. All right, so remember, our zeros are where it's crossing the x-axis. All right, so this is a 0, this is a 0, and this is a 0. However, we have a problem because we can only have one radius. Well, if we think about this logically, right, these zeros are going to be negative, right? So logically, that doesn't make any sense. We can't have a negative radius, right? That wouldn't make any sense. So these two are out of the question, okay? Can't be those two. It has to be this one. So we're simply just going to solve for that on our calculator. You can do this a couple of ways. You can just hit the trace button and trace the function. Or you can actually calculate the zeros by going to second and then going to trace, and there should be a 0 button where you can calculate the 0. So I'm going to do that. And when we do that, the 0 here is going to be 6. X equals 6. Or in our case, sorry, it's going to be r, right? R equals 6. So our radius here is going to be 6. Okay? So that's a real-life application, how you can use a polynomial function, finding the zeros, and apply it, okay, to a real-life situation. All right?